In this part, we'll be discussing about the transverse section of the stem in case of cycas. Transverse section of the stem shows the following anatomical features. To begin with, the things will be common, that is outermost layer will be epidermis, followed by we have cortex, and inner to the cortex we have the stele. Stele has got the arrangement of vascular bundles in the form of ring. Now here they haven't mentioned epidermis. It doesn't mean it is absent. Epidermis is present. It is having a compactly arranged thick walled cells. Apart from that, there is a presence of several persistent leaf bases. Not what exactly this leaf base is. As we all know, cycas has got foliage. When these leaves are going to, that is foliage, when they are going to fall off from the stem, they are going to leave a kind of a scar, that is a mark. These scars are nothing but the leaf bases. Now because of that leaf bases, epidermis appears as discontinuous and feels like it is ruptured here. Haradante. It is ruptured here and it is discontinuous. Now inner to the epidermis, what we have, the cortex. Cortex is the wide region, wide zone in case of cycas stem. It consists made up of a thin walled parenchymatous cells, and some cells are filled with the starch grains, which is going to act as a reserve food material, and also contain various amount of mucilage canals. Now these mucilage canals, they are being shown in the pith region. They are even present in the cortex. Some says these mucilage canals are the reservoir of water, and others says these are secretory in function and they are going to secrete the mucus. By secreting the mucus, these canals are going to act as a home. Home for whom? Home for bacteria, home for the algae, that is cyanobacteria. So they can be in a symbiotic association. Speaking about the periderm now, periderm indicates that the stem of the cycas is going to show us a secondary growth, that is the formation of the cortex followed by formation of the secondary cortex, cork cambium and cork. Together these three layers are going to form what is called as periderm. We have spoken this in detail in our secondary growth clip. So secondary growth is even seen in the cycas stem, that is in an extrastellar region. Now speaking about the stele, here the stele is ectofloic kind of a stele. Ectofloic siphonostele, where we can see formation of the leaf traces. Now the leaf traces are two types in case of cycas. This is another peculiar character. That is, one type is called as griddle trace, another one is a direct trace. This diagram, this one, shows us clearly griddle trace as well as a direct trace. Now speaking about these, what exactly leaf trace are? These leaf trace, they are nothing but a vascular supply to the leaves from the main vascular bundle. This is the main vascular bundle. From the main vascular bundle, some part of this vascular bundle gets separated. That separated part we are going to call it as a leaf trace. That will enter the leaf, young growing leaf, and it is going to form the vascular cylinder of that leaf. So they says that these leaf traces are nothing but a vascular supply to the leaves from the main vascular cylinder. This is what we mean to tell you. If this is the stem, from the stem what arises is leaf. So this will be the leaf base. Here we have this vascular cylinder. More enlarged view. So this is going to form the leaf base. Here if we consider this as a vascular cylinder, small part of the vascular cylinder gets separated. This small part, see, that's the reason it is having this C shape. This small part which got separated, we are going to call it as a trace, leaf trace. This leaf trace, it is going to enter this leaf base. Through the leaf base, it will enter the leaf and form a part of this leaf, vascular cylinder of this leaf. This is the principle behind. Now there are two types of leaf traces. One is direct, another one is griddle in case of cycas. This is how the picture is. One is Here, this is a griddle trace and this is a direct trace. This is the leaf base. Both are entering the leaf base, and through it is going to form a cylinder part of the leaf. Now these direct traces, this direct trace, they are going to originate from the vascular cylinder. This is the vascular cylinder. From them, what is going to originate is the leaf trace. Another griddle trace, it is going to arise from the same vascular cylinder, but opposite to direct. This is direct, opposite to this one is the griddle trace. So the direct trace originate from the vascular cylinder, right? This lies in front of the leaf base, while the griddle trace developed from the vascular cylinder, lying opposite to the direct trace likewise, and it is going to surround and enter this leaf base. While it is going to surrounded by the cylinder, it is going to form this arc shape. This arc shape is nothing but we are going to call it as a griddle. So the trace which is going to form this arc shape, we are going to call it as a griddle trace. Both are going to enter the leaf base. Through the leaf base they will enter the leaf, and they are going to form the vascular cylinder of the leaf. So this was a description regarding the leaf traces, which is again a peculiar character of the cycas. On the picture here, this is the secondary growth. Secondary growth in case of cycas stem, where we can see the first cambium which was formed here, this cambium. So now speaking about the vascular bundle, here xylem has a xylem, this black color region is xylem trachea, whereas these loosely arranged parenchymal cell, these are xylem parenchyma. So both together are going to consider what is called as xylem. Xylem is devoid of xylem vessels here. Another part will be there, that is called as xylem vessel. It is absent in case of cycas. So xylem vessels are absent. In case of phloem, we have phloem parenchyma. These vertical row of cell, this is nothing but a phloem parenchyma, and these horizontal lines are nothing but sieve tubes. So phloem has phloem parenchyma and sieve tubes. It is devoid of companion cells. Xylem is devoid of xylem vessels. Phloem is devoid of companion cells. In between the phloem and xylem, what we have is primary cambium. Now this primary cambium, it is having a short lifespan. It is going to replace it by the secondary cambium and leading to formation of the secondary growth. This is what we can say. There are the developments of one or more concentric rings of the vascular bundles. That is, this will be the first one. Likewise, we have the second vascular bundle, third. Likewise, it is going to show the secondary growth with the more number of xylems. That's the reason it is called as a polyzyclic stem. So this was a description regarding the stem of the cycas. Thank you.